Let's now move on to review how we solve logarithms that include fractions. And to do so, let's begin by reviewing negative exponents. A term with a negative exponent is equal to the reciprocal of the same term with a positive exponent. So x to a power of negative a is equivalent to x to the negative a over 1. So for the reciprocal, we want to switch the terms in the numerator and the denominator. And when we do so, the power or the exponent negative a becomes positive. So if a exponent is negative in the numerator, it will become positive in the denominator. Or if an exponent is negative in the denominator, such as in the fraction 1 over x to a power of negative a, this power will become positive if we switch the terms in the denominator and the numerator. So an exponent that is negative in the numerator will be positive in the denominator. And conversely, if the power is negative in the denominator, it will be positive in the numerator. So keep this in mind as we make our way through the remainder of this chapter. So an example, let's say we had 2 to a power of negative 3. We can make this positive by taking this term and moving it to the denominator. So 2 to a power of negative 3, which is equivalent to 2 to a power of negative 3 over 1. We can make it positive by making the term 1 over 2 to a power of positive 3. And 2 to a power of positive 3 is equal to 8. So 2 to a power of negative 3 is equivalent to 1 over 8. Now let's take a look at how these negative exponents apply to logarithmic functions. The logarithm of a fraction with an integer base will be equal to a negative number. So for this example, we have a log of base 2 of 1/8 is equal to negative 3. And if we want to convert this function to exponential form, we have our base 2 raised to a power of negative 3, and that equals our argument 1/8. So we see 2 to a power of negative 3. Since we have an exponent that's negative, we want this term in the denominator to make this power positive, giving us 1 over 2 to a power of 3, which is equal to 1/8. So this is the relationship between having a base that is an integer, a power that is negative. It results in an argument that is a fraction. So let's take this information and apply it to an example from the beginning. Let's say you're asked to evaluate a log of base 3 of 1/9. What is this equal to? So here's what we do. Step 1, we want to set the function equal to negative y. When we see a base that is an integer and an argument that is a fraction with a numerator of 1, we can go ahead and set this function equal to negative y. And now we can convert the function to exponential form. So we have 3 to a power of negative y is equal to 1/9. And now 3 to a power of negative y is the same as 3 to negative y over 1. And if we look at our numerators, 3 to a power of negative y is equal to 1. That's not going to help us solve for y. In our denominators, 1 is equal to 9 is not true, so that doesn't help us. So that's the clue that we want to switch these terms. So we move this numerator to the denominator by making this exponent positive. So that's step 3. And when we do so, we get 1 over 3 to a power of y. And now we see our numerators. We have 1 is equal to 1. So that makes sense, but that doesn't help us. So now we examine our denominators. And we have 3 to a power of y is equal to 9. So since we can have a base of 3 and wind up with a product of 9, we're going to use our denominators to help us solve for y. So step 4, we want to set our denominators equal to each other. And now step 5, we want to multiply the base 3 times itself until the product is equal to 9. And we know 3 times 3 is equal to 9. So we find that we have to multiply the base 3 times itself 2 times in order for it to equal 9, letting us know that y is equal to 2. And if y is equal to 2, that lets us know that a log of base 3 of 1/9 is equal to negative 2. So when we see a base that is an integer and an argument that is a fraction with a numerator of 1, that lets us know that we are going to wind up with a negative power. So that is how we go about evaluating a logarithm of a fraction with an integer base. Let's now have you try a few practice questions. Evaluate question number 1, log of base 2 of 1/16. Question number 2, log of base 4 of 1/256. And question number 3, log of base 5 of 1/125. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we are given log of base 2 of 1/16. So step 1, we want to set the function equal to negative y, since we see that we have a base that is an integer and an argument that is a fraction with a numerator of 1. And now that we have our logarithm set up, we can convert the function to exponential form. So we have our base 2. We raise it to a power of negative y and set that equal to 1/16. And 2 to a power of negative y is equal to 2 to negative y over 1. And now we want to make this exponent or power positive. So we do so by switching the terms in the numerator and the denominator. And now we find that our numerators are equal to each other. 1 is equal to 1, but this is not too helpful. So now we look at our denominators, and we have 2 to a power of y is equal to 16. And this is helpful because 2 can be multiplied times itself and result in 16. So step 4, we set the denominators equal to each other. And now step 5, we multiply the base 2 times itself until the product is equal to 16. 2 times 2 is equal to 4. 4 times 2 is equal to 8. And 8 times 2 is equal to 16. So we find that we multiply the base 2 times itself 4 times, letting us know that y is equal to 4. And if y is equal to 4, that lets us know that a log of base 2 of 1/16 is equal to negative 4. So that is the answer to question number 1. Let's now have a look at question number 2. We were given log of base 4 of 1/256. So since we have a base that is an integer and an argument that is a fraction with a numerator of 1, we're going to set the function equal to negative y for step 1. And then step 2, we are going to convert the logarithmic function to exponential form. So we take our base 4, raise it to a power of negative y, and set that equal to the argument 1 over 256. And 4 to a power of negative y is equal to 4 to a power of negative y over 1. And now we want to make the power negative y positive by switching the terms in the numerator and the denominator. When we do so, in our numerators we have 1 is equal to 1, and in our denominators we have 4 to a power of y is equal to 256. So step 4, we are going to set our denominators equal to each other, giving us 4 to a power of y is equal to 256. And now step 5, we want to multiply the base 4 times itself until the product is equal to 256. And when we do so, we get 4 times 4, which is 16. 16 times 4 is equal to 64. And 64 times 4 is equal to 256. So we find that we had to multiply the base 4 times itself 4 times. So y is equal to 4, which lets us know that log of base 4 of 1 over 256 is equal to negative 4. That is the answer to question number 2. Let's now have a look at question number 3. We're given log of base 5 of 1 over 125. So since we have an integer base and an argument that is a fraction with a numerator of 1, step 1, we want to set the function equal to negative y. And now step 2, we want to convert the function to exponential form, giving us 5 to a power of negative y is equal to 1 over 125. And 5 to a power of negative y is equal to 5 to a power of negative y over 1. And now we want to make this power positive by switching the terms in the numerator and the denominator, which would result in 1 over 5 to a power of y. And we see that our numerators are equal to each other. 1 is equal to 1. And our denominators are equal to each other. 5 to a power of y is equal to 125. So step 4, we are going to set our denominators equal to each other, giving us 5 to a power of y is equal to 125. And now step 5, we want to multiply the base 5 times itself until the product is equal to 125. 5 times 5 is equal to 25. And 25 times 5 is equal to 125, showing us that we had to multiply the base 5 times itself 3 different times in order to equal 125. So if y is equal to 3, that lets us know that log of base 5 of 1 over 125 is equal to negative 3.